Hey everybody, so today we're going to be reviewing scientific notation, fractions, decimals, and percents, and how to change them into different formats. So some scientific notation review. So remember that we have scientific notation because we want to be able to write really small, so things that are less than 1, or really large numbers quickly, so things that are really large, like we're talking in the millions, the billions, even the thousands, or even the hundreds, but it's still a large value. So what does it look like? Well, any number that's properly written in scientific notation is going to have a number, this coefficient, that is greater than or equal to 1. So this first number that we see here, in this case it's a 4, it must be something that is greater than or equal to 1, but less than 9. So it has to be a number from 1 to 9. You can have a decimal, as you see here, and you can have as many numbers as you wish after the decimal. You're going to multiply that by 10 to some power. This number here, this base number, always is a 10. And then the exponent tells us what type of number we have. So if that exponent is negative, it tells us that we have a very small number, something that's less than 1. If that exponent is positive, then we know we have a large number. And this exponent really tells us how many spaces to move our decimal. So if the exponent is positive, you want to make the number big, so you're going to move your decimal to the right. If your exponent is negative, that tells you it's really small, so you're going to move your decimal to the left. Okay? So we're going to take scientific notation, as we've been given here, and change it into standard form. So first off, it's written correctly. You've got one number in front of the decimal that's from 1 to 9. It's a 4, so that's good. You do have some spaces after the decimal, and that's perfectly fine. We're multiplying by a 10, and we have a power of 2. That 2 tells me I've got to make the number larger than 4.35. So to do that, we're going to move 2 spaces to the right to make it larger. So 4.35 times 10 to the second is the same thing as 435. However, if I have 4.35 times 10 to the negative seconds, now I have a small number. We're going to move 2 spaces to the left, and we'll fill in with a 0. So I have a decimal, a 0, the 4, the 3, the 5. Sorry about that, because you heard my phone ring, so I paused for a moment. Now, that's what it looks like as we move to what's called standard form. Now we have standard form, and our goal is to turn it into scientific notation. So if you don't see a decimal, that means it's at the end. This is a large number, 43,200. If it's large, I know that it's going to be times 10 to a positive exponent. I also know I want this decimal to move so that there is just one number from 1 to 9 in front of it. So we're going to write 4.32. I don't have to write the zeros. I only have to write the non-zero numbers. And once I get to the last non-zero number, I don't have to write anything else. So the question is, how many times did we actually move the decimal? I went 1, 2, 3, 4. That tells me that my exponent is 4. Likewise, we're going to write another number times 10 to the negative, because notice it's something that's less than 1. So we've got to make it small, and the way that we show that it's small in scientific notation is to have a negative exponent. Now I need it so that I have one number in front of the decimal that's between 1 and 9. This 0 is not between 1 and 9, so I've got to move so that it's there to once again get 4.32. The question is, how many times did I have to move? One time. It was a small number, so we say -1. All right, we're also going to just quickly remind ourselves how we go about converting real numbers. So the first thing that we're looking at is how we move from a decimal to a percent. So we've been given a decimal. We can move 2 spaces to the right, or I want you to put a little note that you can multiply by 100. So if I take my decimal and multiply it by 100, I find out that it's 48%. If I want to move from a percent to a fraction, okay, remember that's 97 out of 100. That's literally what we're going to write, because that's what you got, 97 out of 100, because 100 is the best thing. If you can simplify, you simplify. If you can't, like here, we leave it alone. Now, if we're going to move from a percent to a decimal, remember, to go to a decimal, we divide it by 100. So 97% divided by 100, that's going to be 0.97. Now, last year when you were doing this for the next one, from fraction to a decimal, you would have had to have used long division. But now that we're in 8th grade, we are allowed to use a calculator. We just need to know which one goes into the calculator first. So it is the numerator divided by the denominator. That means I would type 3 into my calculator first. Then I'm going to hit divide. Then I'm going to hit the 4. And that's going to give me the decimal of 0.75. Now, because we want to know what that number is as a decimal, we are not rounding. We are not cutting it off anywhere. We are simply writing what shows up in our screen, even if there's 3 or 4 spaces after the decimal. Now we want to go from a decimal to a fraction. Now we've got to talk about place value. We look at where the 6 is. That is the hundredths place. So what that tells me is it's out of 100, and the number that we're looking at is a 6. Now, both of those numbers are even, which means I can divide both of them by 2 to simplify so that I get 3/50. Last but not least, we have how to go from a fraction all the way to a percent. So now remember, to go from a fraction to a decimal, we did 3 divided by 4. We got 0.75. Now I have a decimal and I want to go to a percent. So we multiply by 100 and we get 75%. Now we're going to be really focusing in the next couple days on how to turn numbers into decimals. Decimals are key. And when we talk about scientific notation, we want to go to standard form. So we want standard form or we want decimals, because we're going to start comparing. That's where we're headed with this, but we've got to be able to work with all of it. All right. I hope you have a wonderful day.